Anytime that you have grams and want to find moles, or you have moles and want to find grams, you're going to use molar mass. Going from grams to moles, you divide by the molar mass. Going from moles to grams, you multiply by the molar mass. You don't necessarily need to memorize which operation to use. As long as you write out your units and fill in your conversion factors properly with those units, you'll know whether something is going to go on the top or the bottom of the conversion factor, so you'll know whether to multiply or divide. In this example, we're trying to find what concentration of acetic acid we have made. We put 25.2 grams of acetic acid into water for a total of 0.5 liters of vinegar solution. Our first step is going to be finding the molar mass of the acetic acid, because we need to be able to convert grams into moles in order to plug moles into our molarity equation. We've got 4 times the mass of hydrogen plus 2 times the mass of carbon plus 2 times the mass of oxygen, and we add those up and get 60.052 grams per mole. Now that we have the molar mass of acetic acid, we can convert grams into moles. We take 25.2 grams and divide by the molar mass, which is 60.052 that we just calculated, and that gives us 0.4196 moles as the amount of acetic acid that we're putting into our solution. Our third step is taking that number of moles and dividing by liters of solution to get molarity. So we have 0.4196 moles divided by 0.500 liters, and that gives us 0.839 molar as our concentration. 75.0 milliliters of salt water contains 8.31 grams of sodium chloride. What is the concentration of the salt water solution in units of molarity? Is it A, 1.90 molar, B, 0.00190 molar, C, 0.111 molar, or D, 111 molar? The correct answer is A, 1.90 molar. First, you find the mass of sodium chloride. Then you use the molar mass as a conversion factor to convert grams of sodium chloride into moles. Finally, you can plug those moles into the molarity equation to solve for concentration of salt in the solution. This next type of problem is one of the most common calculations you will do in the chemistry lab if you do any sort of research. We are trying to figure out how to make a particular concentration of solution. In this example problem, we are trying to find how many grams of sodium chloride are needed to make 0.250 liters of a 5.30 molar solution. Again, this is using our basic molarity equation, but in slightly different ways than what you're used to. Our first step is going to be finding how many moles of sodium chloride are needed to make the solution. We know the volume and we know the molarity, so we can solve for moles using a rearrangement of our molarity equation. Our rearrangement is moles equals molarity times liters. We plug in our molarity of 5.30 molar. We plug in our liters, which is 0.250 liters. And that tells us that we are going to be putting in 1.325 moles of sodium chloride. The problem is that we can't weigh out moles in the lab, so we need to change from moles into grams in order to figure out how much to put into our solution. Before we can do that, though, we need to know the molar mass of the sodium chloride. So that's going to be step number 2. We take 1 times the mass of sodium plus 1 times the mass of chlorine and add them together, and we get a molar mass of 58.443 grams per mole. Once we have all that information, we can use the number of moles that we're putting in and the molar mass to change those moles into grams. So we take our 1.325 moles of sodium chloride and multiply by the molar mass of 58.443 grams per mole. The units cancel out, and we end up with 77.4 grams of sodium chloride that we would be adding in to make our 0.250 liters of solution. Since we are trying to make 0.250 liters, in other words, 250 milliliters, we would use a 250 milliliter volumetric flask. We would add in 77.4 grams of sodium chloride and then add water up to the line on the neck of the volumetric flask to give us a total of 250 milliliters of solution. You never measure the volume before adding the solute, because adding the solute can increase the volume slightly. Always put in the solute first, then add water until the total reaches the desired volume. How many grams of sodium hydroxide are needed to make 100 milliliters of a 1.25 molar solution? Is it A, 125 grams, B, 1.25 grams, C, 5.00 times 10 to the 3 grams, or D, 5.00 grams? The correct answer is D, 5.00 grams. First, we change milliliters into liters by multiplying by 10 to the minus 3. Then we plug into our rearranged molarity equation. Moles equals molarity times liters. We do 1.25 molar times 0.100 liters and get 0.125 moles. We find the molar mass of sodium hydroxide and use it as a conversion factor. 0.125 moles times 39.997 grams per mole tells us we need 5 grams of sodium hydroxide.